It's pretty well understood that in general, plants give up about 10 to 20 and even up to 30% of its energy that it works hard to produce to exudates of the roots. And these exudates create relationships. It's a way of communicating to the biology in the soil. What we're doing here basically is farming microbes. And we're using biochar as part of the ingredients of the medium with compost. The compost offers the favorable biology as well as the plant nutrients, and the biochar offers the niche, or the carrier, if you will, for the microorganisms to flourish within, and offers us a better method in transplanting the biology from this spot out to the field. This is what biochar looks like. It's a pretty exciting process. It's a byproduct of the biofuel energy, where any of these organic materials are basically burnt off with the lack of oxygen. So you can make your own biochar with a very basic setup as you see here. You basically have a 33-gallon drum that is solid with the exception of these 5 holes. You fill this drum up with any kind of organic material. In our case, we're using tree trimmings. You want to be fairly consistent with the material that you put in here as far as size go, and you want it to be as dry as possible. So you fill up this drum with those materials, you put the top on, you clamp this on so it's sealed, and you put this in this drum upside down, so those holes are facing down. So it's a sealed drum with the exception of those 5 holes. You put that in here, and you fill the edge, the perimeter between this and this drum. You fill that up with what we use as old pallets that aren't usable again. We cut up the pallets, that wood, we stuff that all in here, and then we burn that. And eventually, the organic material that's in this drum gets hot enough where the oils and the tars that are in the cell structure of the carbon starts to ignite and burns off. And then that's the purpose of these holes. Those gases develop pressure. It's exhausting through these holes at the bottom and feeds that fire. So the material that you put in first in between the drums disappears, and now you're burning the gases. At the end, when it cools down, you end up with biochar. It grows biology like no tomorrow, especially the fungal biomass. Just loves all those little pores and nicks and crannies that's in this biochar. So what we're doing here is Felix and the guys, they're preparing a root zone mix to be tested out in the field. Our next step, we'll go out and see the root zone mixes that we got developed out there. So what we did first is we identified how many coffee cups of sand it takes to fill up those 3 buckets, and made sure it was 100 cups. So that made our math easy on the ratios. So this is 10 cups. So this is 10% of what they call the Miramichi soil enhancer, which is 50% biochar and 50% composted swine manure. And we're making a 10% by volume mix with a USGA sand to test against other inputs like vermicompost, biochar mixed with regular compost, and so on. What we're trying to do is find a better alternative to peats, since peat has some potential agronomic issues and environmental issues when they harvest it. The idea is to use the biochar and the compost that adds a higher CEC component, more nutrients, it holds the nutrients better, and it has a better biology associated with it for plant and soil health compared to, say, peat. In this area here, we have 2 strips, basically, 2 rows, I should say, of varying root zone amendments, including an 8515 standard, industry standard with sphagnum peat. Over here is a Miramichi biochar composted swine manure at 2 different percentages, 5% and 10%, without the peat, all the same sands. And then in this second row here, we have smaller areas of various root zones with different vermicompost, biochar, and whatnot, that including one root zone of profile to test the impacts of those materials. So you can see here the amount of dollar spot scarring that's taken place in the 8515 sphagnum peat as you pan across into this treated area where we have the 5% biochar, 10% vermicompost. You can see there's far less disease occurrence here than there is in the peat.